Hey there. So today I'm going to be talking to you about Project Euler problem number 15. Have it here right in front of us, and they show us a 2 by 2 grid and show us the only possible paths there are to get through this grid moving right and down only, and then they want to know how many ways there are to do it through a 20 by 20 grid. Now there's a few ways you could solve this. You could do it iteratively, which basically you just find each of the possible paths, add them all up, boom, there's your answer. You could do it recursively, or you could do it combinatorically, which is the way I'm going to describe it today, as I think it kind of gives the most simple, elegant solution. I'm going to show you how to do it first here on the 2 by 2 grid, and then we'll use that to figure out how to do it on the 20 by 20 grid. So we have this 2 by 2 grid, and we want to move from the top right to the bottom left, from A to B. Now I could uniquely describe each of these paths with a set of 4 instructions, right? If I told you to go right, then go right, go down, and then go down, right, that would correspond to this path right here. Now we know we're going to have to move 4 times, and we can only move right twice, and we can only move down twice. And we're going to have to move right twice, and we're going to have to move down twice, right? Because we have to get from this left side to this right side, so we're going to have to move 2. We're going to have to get from the top to the bottom, so we're going to have to go down twice. It's just what order are we going to do it in is going to describe each of these paths. So you'll see if I gave you these 4 instructions, but I only told you where to go down, right? It's still going to be obvious because we've already got 2 downs and the only other options are rights. So you would know that it would correspond to this path here. So we can actually reframe this problem as thinking about as in a set of 4 instructions, how many ways are there to give you 2 downs? You can use 2 rights as well, but I'm just going to use downs for this example. Doesn't change anything. Well, we see there could be down, 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 oops, down, down, or down, down, right? Each of these it corresponds to one of these, and there's no other way to do it and have 2 downs in here. Now, that's all well and good here for our 2 by 2 grid. We could just work that out by hand. But for our 20 by 20 grid, right, we're going to have 40 instructions because you're going to have to move right 20 times and down 20 times. So a lot harder to do it that way. Would not recommend it. So what can we do? Well, thankfully, there's something in mathematics called combinations. You could also, if you want more information about it, you can Google the binomial coefficient. But really what it is how many ways are there to choose 2 objects from a set of n objects where the order we choose the objects in doesn't matter, right? It doesn't matter which order I give you the downs, it's as long as I give you 2 downs. So you might have actually seen it written as n choose k, or also n choose k. And there's a formula for this. It's n factorial over k factorial times n minus k factorial. If you don't know what a factorial is, basically it is the product of all the numbers from 1 to n. So for example, 4 factorial would equal 4 times 3 times 2 times 1, which would also be 24. So you can see in our 2 by 2 example, if we've got these 4 slots and I want to figure out all the different ways I can possibly choose 2 slots to put a down in, I'm choosing 2 slots out of our 4. And that's going to be 4 factorial over 2 factorial times 4 minus 2 factorial. And if you work that out, you'll see it's 6. So we can do the same thing now with our 20 by 20 grid, or any n by n size grid, right? So with our 20 by 20 grid, we know we're going to have 40 slots, and we need to figure out 20 of them to stick our downs in. How many different ways are there to do that? Well, it's going to be 40 factorial over 20 factorial times 40 minus 20 factorial. And if you put that into a calculator, you're going to get a really big number. You're going to get 137,846,528,820. That's pretty much all there is to this problem. So if you have any questions about it, just leave a comment below. Thanks.